This is a two-part video for the physics, it doesn't look like a physics, 221 lab, which is the calculus-based physics 2 lab. The first part we're going to talk about percent error, and the second part we're going to talk about sines and cosines. Sines, cosines. We're going to talk about trig functions and the arc functions. Arc, sine, arc, tangent, etc., whatever they are. Okay, so that's what we're going to do. So now we have some data, and we'll call the data new, and we'll call the data old, and we want to find the percent error between the two. Well, we're going to take the new guy, and we're going to subtract the old guy, and we're going to divide by the new guy. Wrong, old guy. Subtract the old guy. Divide by the, do something, I don't know. Gonna do something with it. And that looks good. But percent error is always positive. Always positive. So we're going to take the absolute value of that so that we get a positive number. So we come to our spreadsheet and we have some data, and we have some old data, and we have some new data, and then we're going to go and we want percent error. Percent, where's my percent sign? Percent error. A and B. Yeah, we'll make it a capital A. Well, we'll make it a capital A. We'll leave it there. Okay, so the old data, 2, 3, 4, 5. And the new data, 2.5, 3.7, 3.6, 7.8. And then we're going to go and say, I want the absolute value. Well, I'm going to put an equal sign first. Equal ABS, absolute value of the new guy. So we'll take that guy. New guy minus the old guy. And then another parenthesis sign divided by the old guy. And then I'm going to hit return. And then I'm saying, well, you know, it's not really 25.25%. So I'm going to have to go back and I'm going to have to multiply by 100 to get a percentage. So it's 25% error. And now I go back, copy, paste, and I see that I have a 23% error, a 10% error, a 56% error. So that's how I'm going to do it. I'm going to go and take the absolute value of the new guy minus the old guy divided by the old guy, and I'm then going to multiply by 100 times 100, and that's going to give me percent error. And I'm going to do that every time, and every time you give me a percent error that has a negative sign associated with it, I'm going to mark it wrong and send it back to you. So make sure you do that. Okay, so now the second issue is, how do we take the sine of something? So the sine of 30 degrees is a half, right? And the cosine of 60 degrees is a half. Okay, so we know that. And the tangent of 45 degrees is 45 degrees is 1. And we know that too. Those are things that we should probably know. Clean this up a little bit. So now we go back to Excel, and so I'm gonna take the sine, and I'm gonna take the cosine, and I'm gonna take the tangent of these guys. So I'm going to go sine of what happened? Equal, look before you type. Okay, sine, parentheses, A0. There we go, that's good. Boom. Close parentheses. And I'm going to go cosine, parentheses, A0, A1, A1, A2, A2, enter, and then I'm going to go, well, that seems right, and then I'm going to go tangent, parenthesis, not yet, tangent, parentheses, A2. So that the sine of 0 is 0, the cosine of 0 is 1, and the tangent of 0 is 0. Well, you know, that's all right. So I'm going to copy, and I'm going to paste it down here, and I'm going to go and find the error. So I'm going to find percent error here, and I'm going to go equals, and I'm going to go absolute value. Now we know the sine of 30 is a half, so we're going to take the new guy, which is that guy, minus a half, and then we're going to multiply it, we're going to divide it by the old guy, which is 0.5, and then we're going to multiply by 100, and we have 297% error. What the heck is going on here? Who did that? All right, well, and then we say, well, something's going on. What is it? Well, the problem is that the sine function in Excel is expecting an argument. The argument is what goes inside the parentheses. Expecting an argument in radians. So we come back here and 0 radians is 0 degrees is 0 radians, 0 degrees is 0 radians, 0 degrees is 0 radians. I got the right answer, but the sine of 30 radians is not the same as the sine of 30 degrees. So what am I going to do? Well, I'm going to go and change the argument to radians. R-A-D, radians, right there. Radians, and boom, the other parentheses. Oh, I got it. All right, and I'm going to change the argument to radians. R-A-D, there it is, and close parentheses. I'm going to change the argument to radians. R-A, there they are, and then I'm going to go and copy, and I'm going to paste, and oh, now our error is 1.1 times 10 to the minus 11th when I only have 10 significant digits. That's pretty good. And this looks like the square root of 2 over 2 to me, and that looks like half, and this looks like 0, and this looks close to infinity. So, and this is the square root of 3 over 2. I recognize that. Okay, so when I'm dealing with the trig functions, I have to use radians. Okay, so we got that? All right, so now we're going to go and say, what happens if I deal with the arc trig functions? What do I have to do now? All right, so I'm going to deal with 0, 30 degrees, 45 degrees, 60 degrees, 90, 120, 135, 160, 150, 180, 210. All right, so we'll just deal with those for the meantime. All right, so I've got a 1/2, Okay, because we'll look at this guy, these would be the sine guys. So I got a 1/2, and I got square root of 2 over 2.707, and I got square root of 3 over 2.6866, and I got 90, which is a 1, and what's this guy going to be? This is going to be a 0.60866 again. It's going to be a square root of 2 over 2. It's going to be a 1/2. It's going to be 0. So now I have those guys, and now I'm going to take the arc sine function, and I'm going to get my degrees back. All right, so I'm going to go and I'm going to put a 0 there. So I'm going to take arc, that's not an arc sine of that guy, B8. That's good. Arc sine of B8. And maybe it'd be a good idea to put a 0 there. Alright, so that looks good. I go and copy, and I paste them down here. And wait a minute, I'm supposed to be getting 30 back. I'm supposed to be getting 45 back. I'm getting, the problem is the arc sine function is giving me my answer in radians. Okay, well that's fine. So what I need to do is come back to this arc sine function and tell it that I want it to tell me degrees. So degrees of the arc sine function is what I'm looking for. All right, so that's better. So now I want the arc sine function in degrees. I put them on down into here, and much better, much better. So if I round off to, I'll go and round these off to no decimal points. Right, so format cells, and we want a number, and we want 0 decimal points. Okay, that looks good. All right, so now I get 30, 45, 30, 90, 60, 45, 30. What the heck? This stupid arc sine function is giving me the wrong answer. So what's going on there? Well, can't have everything, I suppose. So if we remember, the sine function does something like that. That's going through 0, and we're back over here to 2 pi or 180 degrees, depending on how you look at it. And the arc sine function is only going to give you an answer between 90 degrees and minus 90 degrees. It's only going to give you the right answer in the first quadrant, and in the fourth quadrant. All other quadrants you won't get the right answer. So if you remember that in the first quadrant, the angle is the reference angle. So whatever the angle is in the first quadrant is the reference angle. In the second quadrant, the angle is going to be equal to 180 if we're dealing with degrees minus the reference angle. If we're in the third quadrant, that doesn't look too much like a 3, but we'll correct that. If you're in the third quadrant, then the angle is going to be 180 plus the reference angle. And if you're in the fourth quadrant, the angle is going to be 360 minus the reference angle, but I don't have to worry about it because my arc sine function is already giving me that back correctly. And same thing with the arctangent function is giving me that back correctly. So if I have something that I know is in the second quadrant, then I'm going to have to go and put in 180 minus the reference angle, which is what the arc function is giving to me. Copy, paste. So now I have to make the correction for my angle, and this is going to be true in your magnetism and electricity thing, for what quadrant I'm in, so that I get the right angle back when I look at the arc function. So not only do you have to put in degrees to get the arc sine out of the radian mode and give me degrees back, but then I've got to correct for the quadrant I am in. Okay, thank you very much. That ends my presentation. Have fun.